ultrasonic tank, which is where the cleaning starts before anything goes anywhere in the anodizing room. Deoxidizer and desmut. Degreaser, which will go in there. Type 2 deionized water, and I need a lot more of that. pH testing kit, scale, lab hot plate. There's my dyes. This is what I'm starting with. There are more colors. There's orange, violet, brown, green. This is a different type of violet, black, deep red, gold, red, Bordeaux, whatever that is, blue, olive drab, temp controller, fish pump for circulating dye water, heater, vent hood, which will vent out the window, runs pretty good, power supply. So the desmutter, deoxidizer will go in there. That one will be a rinse, anodizing tank, rinse tank, I don't know tank, dye tanks, and I'm going to have a dye bucket for each color I've got, but I'm going to start with that for now. Pumps mounted and working good. Radiator that was made in previous videos. Everything is sealed, not leaking, working good. Refrigerator working good. I got the water. I got the water down to 59 degrees. I might be able to get it lower if it has longer. That might be enough. I don't know. I think it needs to get colder, but we'll see. So this is the anodizing room as it sits right now. So last week I was conducting tests on the temp controller. I put the heater in, I submerged the pump, and I want to keep a flow of water around because I don't want these heaters concentrating heat in one area. So if you look here, if I'm concentrating heat, I'm worried that I might melt through the bucket because these get hot. These are always going to be hotter than the water. So I wanted to keep water flowing against that so there's a constant stream of water moving the heat away. And I 3D printed these. They go there to hold the heating element, and then I can just bend these so that they're straight. Sealing agent. Yeah, one of these will be a sealing agent. That's what I was missing. But so yeah, it worked. These are temp controllers for heat. I can wire them for hot or cold or both. I need these to go to 140 degrees and then click off. And then I need these to turn back on as soon as the temperature drops below 140 degrees because I need to keep the anodizing bath at 140 degrees. It does that within 1 degree. So as soon as this hits 137 degrees, it kicks back on. Or 138 degrees. Yeah, 138 degrees. So it'll do nothing at 139. As soon as it hits 138, it turns back on, goes back to 140. This is the pump, and it just hangs inside the tank. I had to 3D print a sled for it to sit on because I want the water to push straight out against the heating element. And my first sled didn't do so well in heat. So I had carbon fiber filament, and this did excellent in the heat. It looks bad because I sanded on it, but the first try didn't go so well. It crumbled in my hands, so I had to do a little research and did some adjustment, and this came out really good. It's pretty strong, it's heat treatable, and this held its shape in the 140 degree water. And when I pulled it out, there was no, it wasn't even hot. It just did not absorb the heat at all. This pump is too wide and it takes up a lot of space in there, but for now I have no choice to use it. I do have a different pump design which I'm going to make, which will reduce the pump diameter to about that much, and it'll be a tube that'll stick straight in there, so that'll free up my space inside there again. Eventually I expect that, you know, these buckets are going to go away and I'm going to go to something else, but a lot of anodizers use these buckets. Some of them like the round ones, some of them like the square ones. You know, these are what was available, and I went specifically with these because I can put these lids on that seal up, and that prevents my water from evaporating. So I just went with that for now, and I think that'll be fine. You know, again, this is to get started. But the test was successful. Everything went as planned. This was the only failure, and the next day I had that fixed with this, and everything has been pretty good so far. This is good. All the wiring are the same on these, so I suspect they'll all work exactly alike. Now, in this case, the temp controller is for cooling. So when the anodizing tank gets to about 168 degrees, then I want the cooling pump, which is that pump right down there, to turn on, and then it'll start running the anodizing tank electrolyte through there, through those tubes. The cold water will cool as it goes to those tubes and then come back into the anodizing tank. I was ready to test that the pump would turn on. I was going to put a heater in the anodizing tank and get everything set up and test that this would cycle on and off like it should. I still have no reason to believe why it won't. And when I took the lid off the anodizing tank, that's what I discovered. Yeah. 2 steps forward, 5 steps backwards. So with any endeavor, being that I've never done anodizing before, there's a learning curve. And sometimes that learning curve can be pretty steep, and there's been quite a few of them with this so far. That said, of all the videos I've watched, the books I've read, the materials I've read, including what I read on Amazon, or not Amazon, but Caswell's website, they're saying distilled water, use distilled water. Well, I got distilled water, and I put distilled water in there, and it turns out that that's wrong. It wants type 2 deionized water, and this takes 16 gallons. And I also need type 2 deionized water in the dye tanks. And I have 4 gallons in each of these tanks. 2 of the rinse tanks needs type 2 deionized water, and the rinse tank after let's see, yeah, after the dyeing, from what I understand, it doesn't matter if it's distilled water or not. So there are some things I can use distilled water for, but for the most part, we got the wrong water, and the dissolved, whatever the stuff dissolved in the distilled water is what's reacting with the lead. So all this has to get thrown out. It's no good, can't use it. And if I want a good quality anodizing, I need to have the type 2 distilled or the type 2 anodized water. And that water has to be run through reverse osmosis before it goes into the deionization. And there's various levels of deionization. So if you have a home deionized water setup, that's not going to produce type 2 deionized water. Type 2 deionized water and type 1 deionized water is lab grade, and I definitely don't need type 1. So yeah, and trying to figure out where am I going to get type 2 deionized water. I can buy 5-gallon drums of it, which is not enough. So what I need is a 55-gallon drum, and they're hovering around $350 to $400 for a 55-gallon drum. So needless to say, I'm just really thrilled right now. So that's where it's at. So this is about to get emptied and cleaned out, and I'm going to have to wash that lead plate up good. But for the most part, this is a complete failure, and that's fine. This is the time to catch it. I didn't want to put water in here and then immediately add the electrolyte, which is right there. I wanted to conduct all of my testing first, and this comes up, and it's just a matter of inexperience. I don't know anodizing, and like I said, it wasn't mentioned anywhere. Everybody, including on Caswell's site, said to use distilled water. So after I did some Google searching on this, I did finally was able to dig up that you do need to use deionized water. And with that, as far as Google goes, thanks to the fact that Google wants to limit what we search for in terms of certain information, and they want to hide things from us, their activities in that area by default bleed over into other searches, as benign as they may be. So trying to do basic searches on just about anything is a lot harder these days, thanks to censorship in this fine, wonderful country. So I don't know how long this is going to keep me down. I was ready to start anodizing after this last test, had it been successful, but I can't conduct the test until I've got this all cleaned out. Now, thankfully, after I had put the water in here and initially tested my pumps, I pulled the pipes out, so none of that garbage is in here, but all this water, it's still holding water, needs to come out. So I will have to purge all the tubing of that old water. But yeah, so anyway, this is the nightmare as it exists. So that has to get fixed. Then I'll be back on track for, once again, testing the pump, make sure that the temp controller turns that on when this gets to a certain temperature and turns that off when that gets to a certain temperature. And then I need it to cycle a bunch of times. And then once I've got that down, then I'm ready to go ahead and add the electrolyte, get the desmutting going, and get the rinses going, and get everything set up like I need to, and then I'm ready to start anodizing. So, I mean, I'm right on the cusp of, finishing, and then this happens. So in a way, it's good that it happens here, but it's just awfully frustrating. And, I'm a little upset that on Caswell's site, the company that sells anodizing supplies, that they're going to say use distilled water when clearly you're not supposed to use distilled water. Anyway, everything else so far so good. This is the hood. I got 2 speeds. That'll vent out the window. I do need to add an aerator to this, and I didn't think I was going to need one, but in researching this problem, I stumbled across that you do need to have like a fish aerator because the solution needs to be heavily oxidized, because what you're doing is you're anodizing aluminum, which is adding an oxide layer. So there needs to be oxygen in the solution. So I do need to have a bubbler. That said, all of the circulation with the cooling and with the basic circulation doesn't have any sort of bubbling. It just moves the solution, and which is what I need, because if I'm not moving the solution, I'm not able to control the temperature of the solution. I don't want to build up hot areas. I don't want to burn the anodizing. I don't want bubbles to build up on the part that I'm anodizing. I want to flush those bubbles off to keep solution on it. So there will be some bubbling going on, but we're going to keep everything moving in this tank so we get a good anodizing. And the same thing goes with here. These will build up bubbles, and keeping the water solution pushed against that helps blow the bubbles off. If that's loaded with bubbles, well, I'm not getting my water hot, I'm getting that hot, and these will pop, and these aren't cheap. So I want to keep solution moving as much as possible. So I'm almost there, not quite. So I do have a pile of aluminum that I bought last week that's ready to be anodized. So once I get this problem solved, I will be hitting it. So anyway, there you go. I'm not editing this. I'm just going to upload it. I don't have a lot of time right now. I just thought I would give an update. I had hoped that after this successful test, I would do a video and, just go through, hey, look at this, we've successful test, and show you the thing cycling on and off, and show you that going on and off. But at this point, I don't know how far this is going to hold me back. I don't really have the funds to blow $500 right now. The dentist has been getting all my money. But, once I'm ready and I'm ready to do the test, I'll have another video, and then that'll be the video where we're concluding the building of the anodizing room. It's basically finished as we speak, but like I said, we'll just get this problem finished and then we can move forward. But yeah, it's taken a lot of work to get this going here. None of this has been easy. Seems like everything in here is giving me a problem. From the resin on that table, that gave me a nice problem. This gave me a lot of problems, and this, I actually wound up welding this up backwards. That tank was supposed to originally be under the window. However, that mess up actually turned out in my favor, because if it had been under that window, you see, I would have had nowhere to mount that hood. So it's actually better that it ended up here than under the window. So that was a mistake that turned out in my favor. You know, 2 steps forward, 5 steps backwards. And over here we got Blackie hiding out on the other side. Angry and as mean as usual. All right, folks, that's it. Until next time.